1/3 big B vertical height. Volumes, what are the units of volumes? Cube. Okay. Volumes are cubes. Cube areas are squared. Remember, volumes are cubed because there are 3 vowels and there are 3 consonants. What? I know. It's pretty impressive. Okay.
Another mark.
Cone, same deal. Cones, just like cones, cone is just a pyramid that has a circle base. So it's just 1/3 pi r squared times how high up for the vertical height. Now remember, when you're putting these things in your calculator, it's literally using the fraction bar for 1/3, and then all the rest of the stuff. You'd be sitting there, if it's repeating, you'd have to constantly hit 3 until the day you die, and then they would still go on. So it's kind of like my heart; it goes on.
What do you divide by?
They divide by 3.
You do that too, but it's easier to just put it. Yep. Much easier. Because sometimes, you have, say for graph, you have 1/3 and 1/2, and you start making all these, you can come up with a giant complex fraction, and it just looks nasty. So that's why I'm trying to stay away from that. Put it in sequence. Throw it in sequence just makes your life easier. It's just a matter of pressing buttons. Okay. What's that? It's not the. Oh yes, the base is a circle. Because cones all have circle bases. So that's why they have their own little formula. All right. Oops. Show. Apparently I saved the wrong file. No, you cannot. You have to gnaw on it to make it sharper. So here's your worst case scenario, just because that's how I roll. I just will throw the more difficult looking things at you right away. Gentlemen, come on. In this case here, we have to figure out what the vertical height is. Well, is it okay that the vertical height is lying sideways? Yes, it's still from the center of the circle to the peak of the cone. What's different here is that you are given an angle at the peak. So if you look at it, you have to use what trig function to figure out that other leg? Tangent. Very good. I have to use tangent to figure out the vertical height of this one, even though, remember, it doesn't have to be, cones don't always have to be standing upright, they could be sideways, so this is still technically the height there. So we have to use tangent. What do you do when your variable's on the bottom? Change-o. Bless you. So we have 13 divided by the tangent of 32. 20. I get 20.8 for my vertical height. So 1/3, 13 squared, 20.8 times 5. And we type it in our calculator just like that. Your fraction bar. No, it doesn't matter. I have a volume then of 3,681.11 something cubed. Okay.
So it's going to go through.
It's just, thank you, sir. It's just like we've been working on. It's always just, for most of these things, it's straight formulaic work that really nothing changes. Okay. Absolutely. This is why these last few sections of the year are usually pretty nice. Okay. All right. Yes, sir.
Is knowing
Bless you.
all your square numbers to like say 12, 16, 20 gonna be helpful? Like,
You know all your you know like 2 square, 3 square, 4 square, and so on.
yeah.
I mean, if you know,
yeah,
I mean,
that's what I was.
it's not bad for when you get the factoring out too, but a lot of times you're not gonna have to worry about that so much.
Okay, because I know all my squared numbers to 16. I can say 6.
All right, well, let's change this up a bit. Let's solve for a part. Let's solve for a part. No hate triangles. Better yet, don't worry about trying to draw it. What are you trying to, what is this asking you to solve for? The height, okay? This one's asking you to solve for the height. What are they giving you? The volume, one of the legs, and you need to find the other leg of the triangle, correct? Yeah. Okay. So, we're looking at a volume of a pyramid. This happens to be a triangle-based pyramid. Exactly. So start with the formula. Volume is 1/3 big B, how high up, how tall it is. Well, in our case here, big B is a triangle, which is a 1/2 base times height.
1/3.
Big B, okay. Now, in a right triangle, you have a 6 and a hypotenuse of 10. What's your missing side length? 8, very good. It's a triple. 3, 4, 5 creates 6, 8, 10. If you don't remember that, is at the end of the roll, you press the buttons on the calculator, use Pythagorean theorem. Nope. Bless you. So when you have your bases and heights, you substitute back in. That gives you a big B. What's half of 8? 4 times 6. So big B is 24. All right. I'm trying to figure out what the height is. Volume is 1/3 big B times the height. Your volume was 56. 1/3 of 24. It's a one-step equation, ladies and gentlemen. Can you scroll back? Excuse me. Oh. Pressing some buttons in the calculator again, because that's really all you have left to do here. Figure out what is 1/3 of 24. 8. 1/3 of 24 is 8. And there's your height. It's just taking a real fast formula. Solving for a part. Okay. It's nothing that we haven't done. Okay. It's absolutely nothing we haven't done. Next. Okay.
You have 3 problems on the one by which you're to find the volume of the big thing and subtract the volume of the small.
With the cubes, I'm sorry, what's that? That gives you the 260.
If you take a cone and cut it in half, isn't that called that's called something? Cut the top off the cone. It's
It would be like.
It's easy.
no.
Okay, so you gotta take
Yeah,
the whole cube
it's
and then you gotta
it's called something. It's like a phantom.
That's it. They gave you all
Do you feel like I do? Right, I think it's called Franklin, or, you got the internet, Google it.
What do I look up?
I don't know, figure it out.
What is it? Look on slide
Here, as you guys have noticed, the overall volume would be the volume of the prism. Subtract the volume of the cone.
But since it's a cube, can you do 6 cubes?
That's exactly what it is. Now remember, since the prism here is all by sixes, remember how we talked about that yesterday. When you have the volume of the prism, it's the area of the base times how far apart they are. And if you recall, that just meant multiplying all three parts together. So the volume of the prism, what is that, 256?
It's
216. 216. So that would be 216.
Yeah.
Subtract out then, well, 1/3. If the base of the circle has a radius of 2, that means the area would be 4 pi. And how tall was that circle? 6. Okay. What's 1/3 of, yes ma'am? 6 times 6 times 6.
And what did you do it
Well, there's only 3 sides.
Oh, so you were basic, like add all four on the bottom side.
On formulas. We're not talking surface areas. Okay. Now, what's 1/3 of 6? 2. What's 2 times 4?
8.
216 minus 8 pi cubic millimeters.
exact answer.
You can. I didn't have calculator in my brain. So it's gonna be 216 minus 24-ish. So you're at 290 or 191-ish. 190. So what did I say? 191-ish. Pretty close. Yes, ma'am. Okay. Just press buttons to the calculator. Now, one of the things you could do. What if I asked you for the surface area of that? What if I asked you for the surface area for that?
So you take,
You gotta do the prism.
All right, hold on. Let's change this up a bit. What if I ask for the surface area? Think about the object, the cube. So first thing we'd have to do is find the surface area of the rectangular prism. Okay. Now, the minute that I cut out a cone, am I adding or subtracting?
Adding.
I'm adding
Because you're going into it.
and subtracting surface area.
Oh, yeah, you're
I'm adding the surface area of the round, but I'm taking away the circle. Everybody see that? So I'm adding surface area to it by the inner round part, the cone, the cone of silence. But yet I'm leaving, because there's area here, but I can't, I can take
Oh, wow.
I can take that and I can wrap up the inside of her cone, but then the circle is still there.
You saw.
The circle of silence.
See what I'm saying?
Nice.
You're welcome. So look what happens here. You take the surface area of a prism, you add the surface area of a cone, guys, enough, and you subtract the area of a circle. The reason why I'm subtracting the area of the circle is because I can't cover it. Okay? So if you piece that together, write out formulas. Well, surface area of a prism, twice the area of big B, plus the perimeter, how far apart they are. Surface area of the cone was pi r squared plus pi r l. Circle is minus a pi r squared. Okay? So it doesn't look like it's horrible.
Well,
Because
wait,
hold on.
You can't
Hold on.
out.
Hold on. You're on the right track. Why don't you write something down so you remember it? As you get into this, it's, again, composite figures. It's a matter of just going piece by writing down what you know. You have everything in the example, or in the diagram, except for one piece. What part is that you're looking that you have to find? What don't you have shown to you? The slant height, very good. You don't have the slant height. Slant height is found by radius, vertical height. 2 squared plus 6 squared. Take the square root. Okay. What's 2 squared? 4. What's 6 squared? 4 and 36 is how much? 40, which means my slant height is 2 root 10. Okay. Just by using Pythagorean theorem, you had to solve for one part. That's it. The rest of it's easy. Twice the area of the base. What's 2 times 6 by 6? Perimeter of the base. Well, the perimeter of the base, there are 6's and there's 4 of them. What's 6 times 4? Plus 24. And how far apart are they? 6. And like Austin was saying here, pi r squared minus pi r squared is 0. Our radius was 2 times 2 root 10. Actually, I'll put my pi here so it's easier to type in the calculator. And that gives me my answer, some sort of a decimal. All right. It's the idea that were you adding or are you subtracting, or are you doing what to an object? In this case, you were doing both. You were adding and subtracting. Okay? Whereas if I turned it around and just did this, if I did something like this, the cone on top, if I did surface area, what would I have to do? I have to subtract out 2 circles, okay? Now, if I'm doing volume with this, do I have to do anything? No. I don't have to do anything with the volume when I'm adding things together. I don't have to worry about formulas, I don't have to worry about backing anything out whatsoever, because I can still fill this all full of water and I'll have the same amount. I wouldn't have to worry about it. Whereas if I'm trying to wrap this up in wrapping paper, I'd have to subtract out 2 of those circles. Okay. Does that make sense?
Sometimes we should do something with surface area and wrapping paper.
Let me pull this up real quick.